Okay, good afternoon, BSMT2. Our topic for today is about atmospheric pressure. So, atmospheric pressure is defined as the force per unit area exerted against a surface by the weight of the air above that surface. So, there is a diagram. So, you can see this one. The pressure at point X increases as the weight of the air above it increases. The same can be said about decreasing pressure, where the pressure at point X decreases if the weight of the air above it also decreases. Top of the atmosphere, weight of the air in the column applies a pressure to point X. Pressure weight, height. Pressure decreases with increasing altitude. The number of air molecules above the surface changes as the height of the surface above the ground changes. For example, there are fewer air molecules above the 50-kilometer surface than found above the 12-kilometer surface. Since the number of air molecules above a surface decreases with height, pressure likewise decreases with height. Most of the atmosphere molecules are held close to the Earth's surface by gravity. Because of this, air pressure decreases rapidly at first, then more slowly at a higher level. Since more than half of the atmosphere's molecules are located below an altitude of 5.5 kilometers, atmospheric pressure decreases roughly 50% to around 500 millibars. Within the lowest 5.5 kilometers, above 5.5 kilometers, the pressure continues to decrease but at an increasingly slower rate to about 1 millibar at 50 kilometers. Isobars, line of constant pressure, a line drawn on a weather map connecting points of equal pressure is called an isobar. Isobars are generated from the mean sea level pressure reports and are given in millibars. Pressure gradient force directed from high to low pressure. The change in pressure measured across a given distance is called a pressure gradient. The pressure gradient results in a net force that is directed from high to low pressure, and this force is called the pressure gradient force. The pressure gradient force is responsible for triggering the initial movement of air. Realist Force, an aircraft under the path of the Earth's rotation. Once air has been set in motion by the pressure gradient force, it undergoes an apparent deflection from its path as seen by an observer on the Earth. This apparent deflection is called the Coriolis force and is a result of the Earth's rotation. As air moves from high to low pressure in the northern hemisphere, it is deflected to the right by the Coriolis force. In the southern hemisphere, air moving from high to low pressure is deflected to the left by the Coriolis force. Due to the Earth's rotation, objects deflected to the right in the northern hemisphere and object deflected to the left in the southern hemisphere. The Coriolis force is zero right at the equator. Okay, the next topic is weather system. Different parts of it have very different types of weather, which also vary through its lifetime. The most significant weather is cloud and precipitation, occurs in discrete lines or fronts. In the northern hemisphere, winds blow anti-clockwise around areas of low pressure. This is reversed in the southern hemisphere. Weather is the state of atmosphere to the degree that it is hot or cold, wet or dry, calm or stormy, clear or cloudy. Weather describes as the condition of the atmosphere over a short period of time, from day to day or week to week, while climate describes average conditions over a longer period of time. Step outside and you experience many facets of weather. Humidity are temperature and pressure, wind, speed and direction. Cloud cover in type and amount of form of precipitation are all atmospheric characteristics of momentary condition we call weather. The sun is ultimately responsible for the weather. Its rays are absorbed differently by land and water surfaces. Equal amount of solar radiation hit the ground more quickly than they do water. Differential warming in turn causes variations in the temperature and pressure of overlying air masses. As an air mass warms, it becomes lighter and rises higher into the atmosphere. As an air mass cools, it becomes heavier and sink. Pressure differences between masses of air generate winds, which tend to blow from high pressure areas to areas of low pressure. Fast moving upper atmosphere, winds known as jet stream, help move weather systems around the world. Large weather system called cyclones rotate counterclockwise in northern hemisphere. Clockwise in the southern hemisphere, they are also called lows because their center are low pressure areas. Clouds and precipitation are usually associated with this system. Anticyclones or highs rotate in the opposite direction and are high pressure areas, usually bringing clearer skies and more settled weather. The boundary between two air masses is called a weather front, where wind temperature and humidity change abruptly, producing atmospheric instability. When things get out of balance in the atmosphere, storms develop, bringing rain or snow, and sometimes thunder and lightning too. A front is the boundary between two different types of air masses. In our latitude, a front usually separates warm, moist air from the tropics and cold, relatively dry air from polar regions. Fronts move with the wind at the front. The heavier cold air undercuts the less dense warm air, causing the warm air to rise up over the width of cold air. As the air rises, there is cooling and condensation, thus leading to the formation of clouds and rainfall. Consequently, fronts tend to be associated with cold and rain. Three types of fronts can be identified: warm fronts, cold fronts, and occluded fronts. Warm front. A warm front marks the leading edge of a warm air mass. The presence of warm front means that the warm air is advancing and rising up over the cold air, this is because the warm air is lighter or less dense than the colder air. Warm air is thus replacing cold air at the surface. Transitions from cold air to warm air. On colored weather maps, a warm front is drawn with a solid red line. Cold front. This marks the leading edge of colder air. The presence of a cold front means that cold air is advancing and pushing underneath warmer air. This is because the cold air is heavier or denser than the warmer air. Cold air is therefore replacing warmer air at the surface. Transition zone from warm air to cold air. On colored weather maps, a cold front is drawn with a solid blue line. Occluded front or occlusion. Occlusions are slightly more complex than warm or cold fronts. They occur because cold fronts travel more quickly than warm fronts, and eventually this results in the cold front catching up with the warm front. This causes the warm air to be undercut and lifted up from the surface. When a cold front overtakes a warm front, on colored weather maps, an occluded front is drawn with a solid purple lines. Stationary front, a front that is not moving. When warm or cold front stop moving, it becomes a stationary front. Once this boundary resumes its forward motion, it once again becomes a warm front or cold front. A stationary front is represented by alternating blue and red lines with blue triangles pointing toward the warmer air and red semicircles pointing towards the colder air. Whereas fronts separate air masses which are different in temperature. Truth generally develop in cold air and are characterized by an increase in frequency and intensity of showers. Pressure begins to fall as the trough approaches and often rises sharply once it has passed. As with fronts, the wind tends to back ahead of the throat and to veer immediately behind it. There are also particularly strong gusts of wind in the showers. Okay, summary. Fronts form as the result of conflict between warm and cold air. Fronts are boundary between two air masses. The most significant weather occurs in fronts since that is where the air is rising faster. Anticyclone. An anticyclone, also known as AI, can be identified in a weather chart as an open, large area of widely spaced isobars, where pressure is higher than surrounding areas. In the northern hemisphere, winds blow in a clockwise direction around high pressure. The higher pressure occurs at the center and is known as the high pressure center. Anticyclone can bring warm and sunny weather in summer, but cold and foggy weather in winter. Depression. A depression, also known as a low, can be recognized on a weather chart by an area of closely spaced isobars, often in a roughly circular shape, where pressure is lower than surrounding areas. They are often accompanied by fronts. In the northern hemisphere, winds blow around depression is an anti-clockwise direction. The lower pressure occurs at the middle of a depression. This is known as the low pressure center. Depressions are often associated with strong winds and heavy rain and nearly always accompanied by fronts. A cold can be identified as an area of slack pressure between two anticyclones and two depressions. The warm sector of a depression is located behind the warm front and ahead of the cold front. It often brings mild temperatures, but the weather can be overcast with drizzle. Part C, plotted weather chart. Plotted weather charts are made up of individual station circles. Each individual station's observation is put into graphical format so that it is simple to understand. Can be put on a chart and be compared to its neighbors. Wind speed and direction. The wind direction is indicated by a line coming from the center of the station circle. The line indicates the direction from which the wind is blowing. On the end of the wind direction line are feather. These indicate the wind speed. Half feather represent 5 knots, whereas full feather indicates 10 knots. A wind with a speed of 50 knots is indicated by a triangle. Combinations of this can be used to report wind speed to the nearest 5 knots. The table shows the symbols used to indicate different wind speed. Cover is indicated by the shading of the center of station circle. The table below shows the meaning of the different symbols. The lecture is plotted to the nearest degree and is located in the top left hand corner of the station plot. Pressure is plotted in the top right hand corner of the station plot. In total, the Mint office has 99 codes for recording the current weather at the time of the observation. However, this can be simplified down different types of weather are represented using different weather symbols, a key to which can be found. Class, our discussion is already finished and hoping that you learn something about my presentation. So, time give you another topic for our discussion. Okay? BSMT2. Thank you and to next meeting.